Guys, there we have the ST-Link, there we have the STM32 F401CEU6 microcontroller based Blackpill board. There is our push button, there is the LED. I press the push button, the LED turns on, else it's off. See, once it's pressed, LED turns on, else off. Now how we did this? So I show you the code in quick succession. So this over here is the code. So on the GUI, we just initialize the two pins. PB3 is a button pin, PB2 is our input, output, the LED pin, and PB3 is the input. Now then we used our programming. Here this is the programming. We initialized those and generated this code, and after that we wrote this command. Whenever the GPIO read pin, port B pin 3 is set, this means if it is button is pressed, only then turn on the LED at pin number 2. That is right command. Else make the LED at pin number B2 go reset, that the state of the pin will go to 0. So this coding gives us this result over here. See. Hello guys, welcome to learning microcontrollers. In this video I'm gonna show you we will be using a push button to turn on off an LED using STM32 F401CEU6 microcontroller based Blackpill board. We will also be using the help of AI to get the syntax. Like we want to write a command, we will get the syntax from the chat GPT or DeepSeek, whatever is preferred. So guys, let's get started. This over here is our STM32 F401CEU6 Blackpill board. Now remember that this is a Blackpill board. The controller above it is sometimes different, so it might be F411, F401 or some other. So you must read this first and then you should take a look at the board, because some boards are not available on the STM32 but controllers are all available. Every controller is available, so you should make this difference. Now to program this, unlike the PIC or Arduino, here we use this ST-Link, this small device. It's very cheap and nearly works with all the STM microcontrollers. Now you have to get this device first, then you can see on it the device is labeled. This labeling is different, pin configuration may be different versions of the device, so you should just look at the labeling. So on the STM32 board you will see that there is a 3.3 volt pin over here, DIO, SCK and ground, and on the ST-Link you will see that you have SWCLK pin here, then SWDIO, ground, 3.3 volt. Now with different versions of the ST-Link V2, you may have these pins shuffled, but the names will be the same. You have to make sure that these are the right pins. Now guys, let's do the connections. Connect the 3.3 volt pin with the STM32 of the ST-Link, ground to ground, SWDIO to DIO pin, SWCLK to CLK pin, like this. In this way the ST-Link is connected. Now we can do the programming using the STM32 Cube IDE. Now guys, the next thing is we need a button. So this is our normal push button, easily available everywhere. It has two pins. I label the left one as VCC, right one as signal. Now remember, this button is not a polar component. You can shuffle these two pins as well. Like you can take the right one as a VCC, left one as a signal, doesn't matter. Now to connect this with the STM32, connect the VCC pin directly with the 3.3 volt pin of your STM32 like this. For the signal pin, you will need a resistor. This resistor will decide either when the button is pressed, a 1 is sent or a 0. Now I will connect this button in such a way that whenever the button is pressed, a 1 is sent. So let's do the connection. Now the signal pin, you connect to one end of this 10K resistor like this. From the same pin, you take out your output. For the output, you can use any available digital input output pin of your STM32. I use the B3. And from the other end of this 10K resistor, you send it to the ground. Now whenever the 10K resistor or the pull up or pull down resistor is connected to the ground of your circuit, one end is to the ground, it means that whenever that button is pressed, a 1 will be sent. If you see that this resistor is connected to the power end, it means that whenever the button is pressed, a 0 is sent. Remember this sign. Now our button is connected. Let's connect the LED. This is an LED. As you can see, it has two pins. One longer, one shorter. Longer is the power, shorter is always the ground, and it's a polar component. It's basically a diode, only allows the current to pass in one direction. So you must connect the longer pin to the positive and shorter pin to the ground, else it will not work. So you connect the ground pin directly with the common ground of your ST-Link. Like you can use any ground pin, this pin or this ground over here or this ground pin, whatever you use, but you just need a common ground of the STM32 like this. For the power pin, use a current limiting resistor, else it's possibility that the current coming from the STM32 may burn the LED. This resistor can be of 220 to 330 ohm. I am using a 220 ohm resistor. Higher the value, the dimmer the LED will go, but it will work. So I'm using a 220 ohm resistor. Connect the longer pin to the one end of the 220 ohm resistor like this. From the other end, you can connect it to any available digital output programmable pin. I'm going to connect it to B2 like this. In this way, our connections are completed. So this is our circuit. Now let me introduce you to the hardware before we move on to the STM32 Cube IDE. Now guys, this over here is our circuit. You can see I have an ST-Link, I have STM32, I have an LED over here, I have a push button over here. Now let's connect this ST-Link with a computer. So just connect it to the extension cable of your computer like this. Now the ST-Link is connected. We can do the programming. So let's get to our STM32 Cube IDE. So guys, when you turn on the STM32 Cube IDE, it asks for the workspace. So STM32 tutorial series on learning microcontroller. This is the folder. Click on launch. Workspace is something like a folder, and there will be subfolders which will be our file names. That is how this Cube IDE organizes your files. So we just opened it. So it starts with the previous one, but go to the left. On the top you have file. Click on new, STM32 project, select it. I have a lecture on this as well, how to download and install this STM32 Cube IDE. So please check that if you have not checked that. Okay, wait, it is creating a new file. Wait. Now this is like STM32 Cube IDE is a very different software than ordinary compiler. It keeps on downloading files from the internet based upon the updates available. So you have to be having a stable connection for this to make it work. So let it download whatever it wants. But it is not necessary. If it is connected to the internet, then you always have latest version. It's a free software. They don't ask for money, but it keeps on updating. So it takes a lot of space as well. So here we go. This is the window that comes up. Okay, wait. Okay, here we go. Now, first of all, go to the board selector. In the board selector, you write down the name of the board, whatever you have. Blackpill. No, it's not available. F401, something like that. Not available. See, your board is not here. So if the board is not here in the board selector, no worries. Go back to the MCU selection. Now here you write the name of your chip. Like I told you, there is a chip on the microcontroller, this board, this chip over here. Now if the overall Blackpill was not available, just write down this name, STM32F401CEU6. That is written on the chip. Just take a look, write it down, and write down here F401. Now F401. Now various models appear. The full name, we write the full name, F401CEU6. Okay, we write F401CEU6. Okay, here it goes. So there we go. Now this is the one we have here. To confirm, just check the specs. So this is indeed the one we have here. So that's all we need. Now click on next over here. At the bottom you have this button called next. Click it. Now this window pops up. Now here you write the name of the project. That will be the subfolder. I write here button based LED triggering tutorial by learning microcontrollers. So that's the name. I click on next and finish. Now wait for the project to be created, a GUI to be established. You have to wait. Okay, here we go. The GUI is here. Now, unlike the other compilers that we use, here you have to select the pins on the GUI. That is a very good feature. So now remember that on the presentation I have shown you that the button is connected to pin number B3. Now go to the B3 and set it to be an input pin. So pin number B3 is over here. No, it's not here. This is B3. PB3, set it to be a GPIO input. Here we go. Set it. Now for the LED pin, set it to be an output pin. So you go there, and we know that the LED pin is connected to pin number B2. So set the B2 to be an output pin. So look for the PB2, port B, pin 2, port B, pin 2, where it is there. Set it to be an GPIO output pin. Now here we go. Now you have to generate the code. It will automatically initialize these pins. Now go to the project. Here you have this generate code. Click on it. Click on yes. Okay, it is generating the C file for you to write the code. So here we go. The file has been generated. Go down. Here you can see it has already generated the file. You just have to write your code, whatever you have to write within the specified area for the user code. Okay, there you write your code. Now to get the syntax of the file, like we want to read a pin, you just take the help from the AI tools. So we go to the Google. On the Google, I write chat GPT. The great thing is the chat GPT generates perfect codes for the STM32. Also all others as well, because STM32 only have one compiler, so there is no problem of mixing up. Now here you write the prompt. Now prompt is very important. I write, I have a STM32 F401 CEU6 Blackpill. Okay, write down microcontroller based Blackpill board. I have connected an LED at which pin? Again confirm, pin number B2. I have connected an LED at pin B2 and a push button at pin B3. Now I have connected push button in such a way that whenever it is pressed, a 1 is sent, else it's 0. Okay, now we have told him about both the things. Okay, now I want you to generate me a code for STM32 Cube IDE. Also mention the version, whichever you have. Version is usually there. Okay, doesn't matter, version doesn't matter, I guess. So we try with the same STM32 Cube IDE. Now I want you to generate me a code for STM32 Cube IDE, which code whenever a button is pressed, LED, whenever a button at B3 is pressed, LED at B2 will turn on, else it remains off. Now he will generate a code and you will get your syntax from there. Okay, let's see what it do. Okay, it understood what I wanted. Okay, now see, he is telling you the same things which we have already done. All we need now, this has been generated automatically. We need only these commands here. See, these are the command we need. Just copy this command, these two commands over here till here. Now go back to your STM32. See, now there was no library here like in micro C. So instead of going to the library, we took the help from the AI tool. So that is not a bad thing. Okay, paste it here. See, now what is happening here? Now if the read button GPIO, this is the syntax, and here you write the port B, pin number 3, that is our button pin, is pressed. GPIO pin set. It means the button is pressed. If it was like 0, if we have connected in such a way whenever a 0 is button is pressed, a 0 is sent, then it was to be a reset. Whenever the pin is reset, okay, button pressed, then pin number, this is another command to write. This is for the read pin and this is for the whole GPIO write pin. This is the syntax. This is your GPIO port. You write the port here, then the pin here. These are the things you have to change. Set the LED. It means the LED will go high. Else, write pin be as 0. So this is the simple code that it generated. We built this code to see if it works or not. Now go to the project. Here you have build project. Click on it. Wait. There should be no error. Okay, perfectly built, no error, no warnings. That's perfect. So the code is built. Now we have to just burn it into the microcontroller. STM32 ST-Link is connected. Click on this button, this green button. Okay, this window pops up. Okay, now click on OK. it is writing. Wait. Okay, it's done. It's successfully written. Now the code is written. Now we go to the hardware and check what has happened. So this is the hardware. This is the button. I press this button. See, the LED turns on, else it's off. See, so it is working perfectly fine. So it was simple as that, guys. See, whenever a button is pressed, the LED turns on, else it's off. That is what we just wanted. See. So this is a very good microcontroller if you know how to write its codes. Basically, its firmware is not that easy, but if you take the help from the AI tools, then you can make your life easy. See, it's working perfectly fine. So guys, this is it. You guys can ask questions if you want, if there is any problem, and please go through the previous videos in the series, like setting up the STM32 cube IDE, and also the how you set up your hardware for LED blinking, and then you come to this video. And if you have some other board, just follow the same step with a different board. That's all you need. So this is it, guys. I hope you learned something from this video. Thank you very much for your time. We'll see you in the next lecture.